Yes, class, am I audible to all of you?
Yes, ma'am.
Khadija,
Yes,
Humaid,
Yes, ma'am.
Yes, ma'am.
Mariam, Fudeja, Leena, Nuha. Yes, class. So in the last class, we had started with kinematics of circular motion. So all the three equations of motions we had seen, if your acceleration is constant, these are the three equations of motions which you can use. So these were exactly similar to what we have studied in motion in a straight line. Those who haven't studied motion in a straight line with me, I think from Thursday or backup classes will start from Thursday. So there we'll discuss all these. But these basic equations all of you are aware of. Fine. So these we had seen, we had practiced, I think, one question only. Derivations we had seen, and yes. Okay, before we start with the next question, there is a concept about conversion. Because we know that SI unit is radian, right? SI unit is radian. So if rotations are given, revolutions are given, so rotation, be it revolution, all these have to be converted into radian. So when one rotation occurs, whenever one rotation occurs, it is from 0 degree to 360 degree. When one revolution occurs, that is also from 0 degree to complete circle, 360 degree. That's why we say whether it's one rotation or one revolution, the value is, the way we convert it is 2 pi radian. Fine. Now, when you are, sometimes you are given to write angular velocity as 1 RPM, which stands for 1 revolution per minute, 1 revolution per minute. So how will you write omega, angular velocity? 1 revolution. So you will write whatever is the number of revolution divided by minute. This is what is the meaning of this. 1 revolution per minute or 1 rotation per minute. So 1 rotation per minute means getting divided. Fine. So now what was 1 revolution or 1 rotation in terms of radian? 2 pi. This 2 pi. If this you can even think like you already have a circle. So what would be the length of the entire circle's angle? We take it as complete angle, that is 360 degree. So this becomes 2 pi radian. Correct? And minutes. So minutes, 1 minute means 60 seconds. So basically you have to write 1 RPM is equal to pi by 30 radian per second. This, if you reduce it, this is how you have to apply it in your questions. Why did I discuss it right now? Because the next question that we'll discuss, it has rotations per minute in it. So whether it's rotation, revolution, because RPM will only be given. So you will not be able to identify whether this is rotation per minute or revolution per minute, right? So how will you figure it out then? No need to figure it out. Whether it's rotation or revolution, both are ultimately giving you 360 degree like this or like this. Fine. So for the conversion purpose, you just have to remember you have to multiply it by pi by 30 to convert it into radian per second, and divide by pi by 30 to convert it into rotation per minute if required. So it says that angular speed of a motor wheel increases from 1200 RPM to 3120 RPM in 16 seconds. This is angular speed. 2 values are given. So which 2 values are these? Initially from a value to a certain value. So initially if it was 1200, it increases to 3120. So initial angular velocity, the way we had u for initial speed. So initial angular velocity, final angular velocity, time is there, acceleration. Just apply all the equations which we have studied. But before we perform any calculation for initial, that was 1200 RPM, what we are going to do first? We are going to multiply it by pi by 30. 0, 0 cancel. This becomes 40 pi radian per second. This is the initial angular velocity. When we are talking about final angular velocity, that is 3120 rpm. This is equal to 3120 into pi by 30. That becomes 104 pi radian per second. You have these in radian per second, initial angular velocity, final angular velocity. You have time also as 16 seconds. So it's like you have initial velocity u, you have final velocity v, you have time t. Here acceleration is asked, angular acceleration. So if you have u, you have v, you have t, you can calculate a using first equation. So here also you will use first equation only. Omega is equal to omega naught plus alpha t. Omega naught we have, alpha we do not, t we have. So this will become 104 pi is equal to, this was 40 pi plus alpha t, so 16 t. This will become 104 pi minus 40 pi, 64 pi. 64 pi divided by 16. So this is 4 pi radian per second square. This is the first part, right? To find out A. This was unknown. Clear? Now come to second part. How many revolutions does the wheel make during this time? Number of revolutions you have to tell. For finding out the number of revolutions, you should know what is the value of theta. How much displacement has occurred? How many angles are made? Then only you can tell number of revolutions. A wheel is there, wheel is revolving. So 1 revolution, 2 revolutions, 3 revolutions. You should know which angle is being made. Then you can multiply. Suppose n number of revolutions are there. So and theta is the angular displacement. So n into theta would give you total number of revolutions, right? Total number of distance that has also been made. That's why first let us find out theta. What is angular displacement? We have all the data with us. Initial velocity, final velocity, time, angular acceleration, everything we have. We can find out theta. See, for the second part, use that equation. S is equal to ut plus half at square. So this becomes theta is equal to omega naught t plus half alpha t square. So theta will be 40 pi into 16 plus half alpha we have calculated 4 pi into this is 16 into 16. This is equal to 152 pi radian. This is the value of theta. So this is the value of theta. This is the number of angles made. Now how will we calculate number of revolutions? See, this is theta. This is not the number of revolution. This is if something is rotating like this. So the angle that is swept is angular displacement. If I have started from this position and I have stopped here. So angular displacement. One displacement is this that is occurring from the tip. Linear displacement which we calculate. If something is occurring like this, angle that has been swept by the time is 90 degrees. So angular displacement will be pi by 2 radian in this case, like this. So similarly, theta is 1152 pi for us. Now see class, we know that 2 pi radians, this makes 1 revolution. Agreed? 2 pi 360 degree will make 1 single revolution. It's like 1 complete lap is making angle of 360 degree. So how much 1 radian would be if you apply unitary method? 2 pi is for 1. So unit radian will be 1 over 2 pi. This 2 pi will go here. 1 over 2 pi number of revolutions. So for 1 radian, if you have 1 by 2 pi number of revolutions, for this much radians, how many revolutions you will have? So for 1152 pi radians, this would be 1152 pi divided by 2 pi. So pi will be cancelled. This becomes number of revolutions, 576 revolutions. This is the number of revolutions. The second part is important. Fine. Now we'll start with torque because a small derivation is also there. But first write down these points. Start writing it from here. And one instruction to all of you, because some of you have your first class today. Do not write while I am teaching. Put your pens down. Understand first. I'll give you sufficient time to copy each and every word. Your speed will determine how much should I scroll. And you all can keep on updating me in the chat column the way other students do. Scroll a little more, scroll down, please wait, like this. You can let me know. But do not write while I'm teaching. All right. Start writing down from here. Yes, class. Now, talking about forces. So see, these were the three questions. When we were studying kinematics also, this was the sequence we followed. First, we had seen how the motion occurs. Motion in a straight line, motion in a plane, these things. Then came the concept of why does motion occur? That was related to forces, right? Now, forces in rotation motion, the force that helps rotate an object, that we do not call it as force, we call it as torque. So moment of force about the axis of rotation is called torque. So see, understand it like this. This is the axis I have drawn, x-axis, y-axis. On one axis, I have taken torque. On one axis, this is position. Now, this is a point P that I have taken. Separation of point P from origin is R. So R becomes the position vector. Fine, from this OP, the separation OP is R vector. A force is being applied here, which is making an angle theta with R. This is extension of position vector only. So this is theta. Now for the derivation purpose, I'll tell you, for the derivation purpose, I have extended this and have drawn perpendicular. Reason is that the radius vector which we use in torque, it is always perpendicular to the axis. Axis of rotation we have, like here, this is the axis. This axis I have taken. Or like you take the example of fan also. Blades are moving, one axis is fixed at the center, but the three blades are continuously moving. If you see, they are continuously moving, right? So because there is torque developed and it is always perpendicular. So see, this extension I have made just for the derivation purpose. Fine, because you have to give derivation also, write derivations also. So this triangle is ONP. In triangle ONP, if I write sine theta, see, theta is actually the angle between force and what is this? This is radius vector. Fine. So these become vertically opposite angles. Now, when we are talking about ONP, this is ONP, this triangle. If I write about sine theta is perpendicular by hypotenuse. Perpendicular is R perpendicular, hypotenuse is R. So what is R perpendicular? R perpendicular is R sine theta. Now come to the formula of torque. Torque is R cross F. This is the formula for torque. Cross product, those who haven't studied, we'll discuss it. Those who have, please revise it. Cross product, dot product, these things will be used now often. So tau is R cross F, product of force and perpendicular distance. Correct. This is actually R F sine theta. So if I take R and sine theta, that will give me R perpendicular. So that's why we say the formula of torque is not just R F sine theta or R cross F. It actually is R F. This is R perpendicular, because R into sine theta is R perpendicular. So the formula becomes R perpendicular into F. So R perpendicular is what? It's the perpendicular distance between axis of rotation and the line of action of force. This was the line of action of force. This was the axis of rotation. So perpendicular line dropped from here. Just for the derivation purpose, you don't need it all the time. Okay, yes. See, SI unit of force is Newton. SI unit of position is meters. So its SI unit becomes Newton meter. This is an axial vector. Its direction is given by right hand thumb rule. You have to curl your fingers along the sense of current and all along the direction of forces. Leave it. Nobody is going to ask you right hand thumb rule in torque in class 11. Just ignore it. Just write it so that at least in your mind you have an idea that yes, direction is also calculated. Otherwise, direct anti-clockwise, clockwise like this will be given. Fine, like this it will be given. See, forces are acting. If forces are acting in different directions, let's say one force is perpendicular already, one force is parallel. Now, how will you handle this situation? Because we don't have to go into the details of torque so much. You have already studied force. Now see, how will we study this? our axis, this is just an example. This is an example that is given. The axis that we have is here. Now we have to calculate. Axis is given over the corner. Look, when I'm talking about the first thing, this separation. Tau is equal to R perpendicular, R1 actually. R1, the separation is R1. Force is F1 sine theta. But see, when the force was actually perpendicular to the rod, F1 here, can anyone tell me what is the angle formed between F1 and R1?
90 degrees.
Very good, Umair. 90 degrees. This is 90 degree. So if this is 90, that is your theta is 90 degree, torque will straight away become R perpendicular into F1. Right? But see, when I am saying about this F2, which is acting parallel to R1, tau will become R2 F2 sine theta. But the problem that will arise is this R1 and this F2 both are already parallel to each other. So angle will become 0 degree, which was earlier 90 degrees. So torque will be 0. So these two special cases can be asked to you in your exam. In which case is the torque maximum? In which case is the torque 0? So this is how you should handle all the questions of torque. Angular momentum I'll discuss first to write down everything about torque, then I'll discuss. Done till here. A very short topic. This is angular momentum because you people have already studied angular momentum, linear one. So what was linear angular momentum? Product of mass into velocity, or how much motion is there, amount of motion in a substance. Like if I say a stone is coming and hitting a wall, the momentum of the stone was very high. This means the amount of motion contained within the stone was very high. Even after hitting the wall, it has a tendency to go inside it. So this property is called linear momentum. Similarly, analogous to it, you have angular momentum. So angular momentum is moment of linear momentum about axis of rotation. You have the formula P is equal to mv. Here, angular momentum is represented by this letter L, angular momentum. So mass into velocity is one formula. This we'll see it later. Before that, before we jump into it, normal formula which is written here is radius into momentum sine theta. Here your r perpendicular is r sine theta. So directly we can write r perpendicular into this. So r cross p. It's actually the cross product, r cross p. Fine, this is the cross product. So see, similar, same diagram, same thing, axial vector, its direction is along axis of rotation. Now see, P is equal to mv. So L will be moment of inertia, mass of the body. We have a term which we call as moment of inertia. Now, moment of inertia means the term is very misleading. Moment of inertia, something very different this seems like. Moment of inertia is basically how much amount of matter is contained when rotation occurs. It's like mass present in rotation. So for that we use the symbol I. So it's just like mass. What is the work of mass when we're talking about kinematics? Same work is done by inertia. Until and unless an external force occurs in your system, body won't change its position. Newton's law, recall Newton's law. And V, that is linear velocity, will become angular velocity. So what was moment of inertia? For moment of inertia, you also have a specific formula for moment of inertia. Moment of inertia basically tells how much is the amount of matter while rotating. When a body is rotating, how much is the matter? So you have a particular formula for it. For example, I have one mass and I want to calculate moment of inertia here. Mass is m1, the axis is r1. Separation from the axis is r1, that is position vector. Then again I have mass 2. Again separation will be there from the axis of rotation, m3, m4, m5, m nth. One formula, remember, inertia is always mass into, basic formula is mr square, basic formula. Mass into square of radius or position vector. But if you have so many, not a single mass, m1, m2, m3, m4, m nth, what will you do? Add all of them. m1 r1 square plus m2 r2 square up till m nth rn square. Like this. Keep on adding. mr square is the basic formula for you. You have to remember mr square. One more thing, class. If mass is not constant, then how will you use mr square? For that one purpose that we have been using throughout. You know, a very small for one mass, if you know. For all the masses, won't you be able to find out through integration? You will expand it. So this is dm into r square. This also you will see wherever this is required. Like, see, this is a very, very basic question. Calculate moment of inertia of a ring about an axis perpendicular to the plane of the ring and passing through its center. It's like this is a ring. I have kept it like this. Like this. In X, Z plane. This was X, Y plane. X, Y. This, if I draw it like this, this will be Y, Z. So YZ plane. If I keep it like this, X, Z. So this plane is like this I am showing. An axis is perpendicular to the plane of ring passing through its center. Like this. Like this. Suppose the radius is r, mass is m. So what will be moment of inertia? Simply mr square. That's it. Values are given, put in the values. Values are not given, don't put in the value. Keep it like mr square. Let's see it properly. First, you write it down so that at least you people understand the moment of inertia and connect it with angular momentum. Then we'll see other questions and how moment of inertia for different shapes are present. But before you people start writing, just tell me, is it clear to all of you? Yes or no?
Yes, ma'am.
So only Humayed has understood, despite
Yes, ma'am.
having first class. Good, Mariam has understood. What about you, Khudeja, Leena?
Yes, ma'am.
Clear? Khadija, Nuha? Fine? Understood till now? Because this is a very important concept. Moment of inertia is a very important concept. You should have a strong grip on it and try to revise it today itself. Now, C class that we discussed, if you have a fixed mass and if radius is there. See, we'll discuss more questions of moment of inertia. This was a very basic question. This you should already remember. This formula, no, mr square for a ring. You will remember it. I'll show you some figures. Disk, ring, perpendicular axis, parallel axis, cylinder, spheres. These all these you have to remember. I'll show you. I'll share a table with you. You will remember it from it. If mass is given which is uncertain, which is not constant, its value is changing. Like suppose if I give you an example, I have a rod. All right, if I have a rod whose length is L, the entire length of the rod is L. Now I have to find out the moment of inertia of a rod, and is the axis given? About an axis passing through its center and perpendicular to its length. So this would be the axis. In rotation, always remember you require an axis. Whether you make it like a proper graph with origin and y-axis as the axis or x-axis, that depends. Like this is mentioned here, so it means this rod is rotating like this. Axis of rotation is this, it means it is rotating like this. If suppose this is the axis is here, so it will rotate like this. If the axis is in the middle, perpendicular, like given in the question, it will rotate like this. See, this is the difference. That's why we have to make sure that axis is written. Now what will I do? If I do not have information, I'll take a very small amount, dm, this mass, dm mass, whose length is dx. I'll take a small length dx. Okay, so I have to find out what is the moment of inertia. All right. Now see, if this is the axis, it's like my origin. It means x is equal to 0 at this axis. It's like your axis. Axis similar to the graphical axis. So if you take the axis, on the right hand side, your x-axis is positive. On the left hand side, it's negative. So this is a negative value. This is a positive value. This I'll tell at the end. First, let us find out the value. See, formula of this will be integration of dm into x square. Now limits. See, that's what I was saying, x square. Now x is also variable here, mass is also variable. So we'll set the limits according to one thing. Let's set it according to x, because we do not have to expand the mass. We'll expand the length. If this is our axis, this side, this is passing through the center, through its length. It means this length will be L by 2. This length will be L by 2. This is given in the question. The axis of rotation is passing from the center. So if it passes from the center, it will divide the length into two parts. If this is the center origin axis, this is 0. So here at the end, this will be plus L by 2. And from this origin to this separation, this will be minus L by 2. Instead, or you can integrate it from 0 to L also. But this is a case of rotation and axis is here. That's why we are not taking it from 0 to L. Understand this class. Let's say the axis of rotation was towards the end like this. This was rotating like this. So what were the limits that we would have chosen? From origin, from here, this end, that is 0 to the entire length L. Now the axis is here. So from here, this is not 0 now. This is minus L by 2. Number line, how do you write number line? Like this, minus L by 2. 2 plus L by 2. This is L by 2. This is L by 2. Correct? If the axis was here, suppose towards the end, along its length, towards the end, not through its center. This would have been the rotation case. From 0, here this point would have been 0 to L. Understood how we have to expand it. So here also, when you are expanding it, see, mass is also variable here and length is also variable here. So how will we integrate it? From minus L by 2 to plus L by 2. But still, dm x square, this isn't making any sense. No, while integrating, limits are of length. Limits are of length. X square is also fine. dm. So dm is what? dm is the mass of dx. So let's find the mass of dx. Let's find out the mass of dx. If dm is what? dm is the mass of dx. Infinitesimally small portion I have picked up so that I can integrate it and find out for the entire moment of inertia. So how will I do? See, if mass of the length L rod is capital M, suppose the entire mass of this rod is M. So for unit length, this will become M by L. For unit length, 1 unit length, it will be M by L. L length, M mass. Unit length, M by L. So if it means this is for 1 meter. For 1 meter, this is M by L. So for dx meter, it would be multiplied with dx. Unit, you know. If you know unit, you can find out for n number of times, right? So unit length mass is M by L. So mass of dx length would be M by L into dx. What is mass of dx? Mass of dx is ultimately no dm. So we have the value of dm. Now substitute this value. Moment of inertia is M by L dx, and what was left? X squared, from minus L by 2 to plus L by 2. Now see, everything is making sense. X square dx can be integrated, and x is telling you about position, distance, and limits are also of position or distance. Now this makes sense. dm was something odd. We have replaced dm. So this is actually M by L. You take it as common. X square dx integration from minus L by 2 to plus L by 2. This is your answer. This is not the answer. It means this is the step how you have to go. This is the final answer where you can simplify. Now it's just mathematics. Now it's just calculus. Entire rotational physics was applied till here. If you are able to solve it this step for rods, for any other masses, whichever variables are given, you will be able to perform the integration. Now see, this is so easy. X square is given. Mass by L is already constant. X square plus 1 power 2 plus 1. Whatever is this is how no we write x to the power n will be x to the power n plus 1 divided by n plus 1. So x to the power 2 plus 1 by 2 plus 1. Power limits are from minus L by 2 to plus L by 2. This becomes x cube I is equal to M by L x cube by 3 from minus L by 2 to plus L by 2. So let's substitute the values of limits now. M by L. Upper limit first, L by 2. L by 2 whole cube. Okay, let's bring this 3 also here. Upper limit cube minus lower limit, that is minus L by 2, its cube. So this becomes M by 3L. This is L cube by 8. Plus, why? Minus minus will become plus L cube by 8. So L cube by 8 plus L cube by 8. This becomes L cube, see, this is 2L L cube by 4, right? This is L cube by 4. I'll show you. M 3L into L cube by 4. So L will cancel this. So what is the final moment of inertia? M L square by 12. This you have to remember also, but that I'll show you later on. This is how you have to solve if variable is given. So ML square by 12 is the moment of inertia for this rod. Write it down at whichever step you get stuck. Get your doubts clarified.